I'm Anil Kumar sharing with you few test questions on application. I'll take up questions related to optimization and rate of change. This is one of the most important topics in calculus. You're almost at the mid of the syllabus here. Now this is unit 3 and these questions are going to help you to prepare for your own midterm test. I've taken examples based on marginal cost, optimum size of container, economical construction of road, closest board distance, and one on position displacement acceleration. Now for some of my students, this term marginal cost is a new term, so here is how we define it. Marginal cost is rate of change of cost at a given level, right? Now, it can also be used to find cost of an item being produced. So here is how it is also applied. Marginal cost of producing 100 units is approximately equal to the cost of producing the next unit, which is 101st unit. So at times in your exam, you might get a question asking for the cost of, for example, 101st unit, then you have to find the marginal cost for 100 units. It really means change of cost. Do you understand? So to find marginal cost, we normally will find derivative of the cost, right? That will give you marginal cost, and that will also give you the cost of n plus 1 item being produced, so the cost of the next item. So I hope you understand the concept, right? Now before taking these examples, let me summarize the strategy which I am going to follow to answer all these questions. Strategy is kind of simple. We'll always try to first sketch, define variables, relate them, and make equations. That is the first step, which is very critical step. So you will be given conditions so that you can define one variable in terms of another. So your equation should be in one variable. The second step will be, once you have that equation, we'll call this as a function. Is it okay? So once you have a function, then you find critical numbers. So critical numbers you can get by finding the derivative, equate them to 0 or does not exist. So there could be two conditions. So that gives you critical numbers, right? So let's say that the critical numbers are Ci. There could be one or more critical numbers. And the third step will be to reason for whatever, right? Maximum or minimum in our case, right? You have to provide reason for that. Now reasons could be provided in different ways. You could use boundary conditions. That is one way. The other way could be that you could analyze first derivative. Correct? And the third way could be you can find second derivative. Is it okay? So analyze first derivative or find the second derivative. And of course, you know, if second derivative is greater than 0, then it's like concave up, you're looking for minimum. And if it's less than 0, is concave down, you're looking at maximum, right? So that gives you minimum, and this gives you maximum. So these are different strategies which you could adopt to reason out maximum or minimum. Perfect. Now let's see how we can apply these strategies for the given examples. The first example here is based on marginal cost. The question here is, the cost in dollars to produce X liters of maple syrup is C of X equals to 75 square root of X minus 10, where X is greater than equal to 400. What is the average cost of producing 625 liters? What is the marginal cost at 1225 liters? And how much production is needed to achieve a marginal cost of, this should be cents, right? So it should be, let me rewrite this. Marginal cost of 0.50 per liter. Is it okay? So that is the question for you. It's a test question. You can always pause the video, answer, and then look into my suggestions. So first part of this question is, what is the average cost, right? So total cost we can find for 625 and divide by 625 to get the result, correct? So in the first case, what you need to do is we need to find the cost for 625 liters and divide it by 625. We'll get our answer. Perfect. Part B is, what is the marginal cost at this level? So now you have to find the first derivative and then its value at 1225 will give you the answer. The next one is, we know the cost, but we need to find that quantity, correct? So that's how it is to be done. So let's begin by answering them one by one. I hope the concept is clear, right? So let's find the average cost. So average cost will be, let's plug in 625 here. So we are trying to figure out 75 times square root of 625 minus 10, and that dollar value will be divided by liters, 625. Do you see that? And so we'll get the value which is like dollars per liter. That's what it is. Units can help you to get to the equation also. Remember that. So we have 75 within brackets, square root of 625, which you know is 25, minus 10, bracket close, equal to, so it is 75 within brackets, square root of 625, and then we have minus 10, bracket closed, equal to 1125, right? So that is the numerator. We have to divide this by 625. So let's divide by 625 to get the average cost, which is 9 over 5. Change it to decimals. So we get 1.8. Correct? So units should be 1.80 dollars and cents. So average cost of producing 625 liters is $1.80 per liter. Okay. Part B. What is the marginal cost at this level? So let's find the derivative. So the derivative for our cost function is, so you could actually rewrite this. So it helps at times. Let me rewrite and show you how it helps. So we can write this cost as 75 square root x minus 750. You get the idea. Perfect. Now, derivative will be, this derivative is 0. So it helps, correct? So square root derivative is 1 over 2 square root x. So we have 75 over 2 square root x. We need to find at this level where x is 225. So let's substitute 225 here. So if x is equals to, 1225, then what? Then the answer will be 75 over 2 times square root of 1225, correct? So let's find this answer now. So we have 75 divided by 2 equals 2. We'll divide this by square root of 225. Let's do it again. So we have 75 divided by 2 equals 2, divided by square root of 1225, and that gives us 15 over 14. In decimals, it is approximately equal to 1.07, right? So the answer here is that the cost is $1.07 per liter. Perfect. So that is how you could do it. Now the last part is, how much production is needed to achieve a marginal cost of that much? So we know the left side now. So we could write this as 0.50 equals to 75 over 2 square root of x. So cross multiply, right? So when you cross multiply, you get square root of x as equal to 75 over 2 times 0.5, and then which is 75, correct? And then x is square of this, right? So what we get here is x is equals to 75 square. So let's do it. We have 75 square equals to 5625, correct? So the answer is 5625 liters. So I hope all this is very clear. So what we did was, to find the average cost, we found the cost divided by the total amount. To find marginal cost, we found the derivative, substituted the level, and this was kind of reverse calculation. We are given the marginal cost, we need to find the level, correct? So let's move on to the next question now. The question here is, the capacity of a cylindrical can is 1000 centimeter cube. If the end pieces are twice as expensive per square centimeter as the wall, find the dimensions to the nearest millimeter to minimize cost. Now let's sketch a cylindrical can first and then define variables. So that is a standard way, correct? So that is our cylindrical can, and let's say this is radius r and that is height h. We are also given that this is more expensive material at the end. So top and bottom is more expensive. So we'll say it is twice. We'll keep this as $1. That becomes $2. Is it okay? So that's what we are given. Now let's look into the formulas. The capacity of a cylindrical can is 1000 centimeter cube. Now capacity means volume, correct? So we have volume is equal to, what is the formula? Area of the base, which is pi r square times height. That is the volume. And volume is given to us as 1000. So 1000 is pi r square h. From this formula, you can always isolate h, so we can relate h and r, right? So generally, we will do like this. We'll say h equals to 1000 divided by pi r square. So we have related height and radius. Do you see that? Okay. Now the next part here is, we are actually interested in minimizing the cost. Cost comes from the material, right? So material cost means we have to look into surface area. Perfect. So now let's look into material cost, which is we have to figure out surface area. So here we have two kinds of surfaces. One is top and bottom, which is circular. So we have surface area could be given as pi r square and pi r square. That means 2 times pi r square, which is top and bottom, right? Plus this surface, lateral surface, which is 2 pi r times height. So that becomes the lateral surface. It's important to write like this since we know the cost is also different. So if I write cost of this function, then see the cost will be, this is twice as expensive as that. So I'm writing 2 times as it is twice expensive. So twice whatever. So we are just taking $1 for here, $2 there. So twice 2 pi r square plus 2 pi r h as the cost function. Now it is a good idea to write only in one variable, otherwise you can't solve it. So h could be written as 1000 over pi r square, and we could simplify. Now what I want to tell you here also, we are actually looking for pi rh. So pi rh also could be written. So let me rearrange this formula once again. So I'll write pi rh is equals to, we don't need that r. So we'll divide 1000 by r. Does make sense to you? So I could replace pi rh by 1000 over r. So that's a good way of doing it. In that case, I get this as 4 pi r square plus 2 times 1000 over r, right? I'm taking my time in showing you all these calculations since they are very critical to understand. Now what you have here is equation in r, right? So we can say this cost is a function of radius of can, right? Now this you could always write this as 4 pi r square plus 2000 over r. Perfect. Now we need to minimize the cost. So to minimize, what will you do? We'll find the first derivative, right? So we'll find first derivative. Okay, so let's find the derivative here. So first derivative, which is with respect to r, so 8 pi r, that gives me minus 2000 over r square. Perfect. Now to find the critical point, we'll equate this to 0. So we say 0 equals to 8 pi r minus 2000 over r square. So at this stage, we actually find the critical number. Let's find r. So bring it to this side. So we have 2000 over r square equals to 8 pi r. So we can cross multiply and solve for r. So let me take it to this side now. Let's cross multiply. So we have r cube equals to 2000 divided by 8 pi. Perfect. So r is equals to cube root of 2000 over 8 pi. So let's find this value. So we have, let's do 2000 divided by 8 equals to, we'll divide this again by pi equals to, and then we'll find cube root, that means power of 1 divided by 3. And we get r as equal to 4.30. So let me write this as 4.3. We have to round to nearest millimeters, so it is 4.3 centimeters. Perfect. So 4.3 centimeters becomes the radius r. Now the question is, how do you know that this is minimum or maximum? So you have to justify your answer. So there are many different strategies, as I said. What I will do here, find the second derivative. So the second derivative, so we are using this function, will be 8 pi, which we know is always positive. And for this part, minus 2 gives me plus 4000 over r to the power of 3. Do you see that? So this is always greater than 0. Perfect. So at this level also, it is going to be greater than 0. That means greater than 0 means concave up. Perfect. So we have a minimum value. So that is a good test. Since we have done higher order derivatives, we could always apply this strategy. So that means we have minimum cost for radius of 4.3 centimeters. Now dimensions means height also, correct? So now find height. You can use this formula. So height is how much? So height is equal to 1000 divided by pi r square. So let's do this here. So we have 1000 divided by 4.3. So pi times 4.3 whole square. So let's calculate this. 1000 divided by pi. Now we'll divide this by 4.3 square also. So that gives us 17.2. So height is 17.2 centimeter. Is it okay? So this is 17.2. So that is how you could actually do this kind of question. Each and every step is here very important. Missing them means you are losing marks in your final test. Okay. So take care of it, and I hope that works. Thanks for watching. Let's move on and do the next question now. Now the question here is, an animal breeder wishes to create 5 adjacent rectangular pens, each with area of 2400 meters square. To ensure that the pens are large enough for grazing, the minimum for either dimension must be 10 meters. Find the dimensions required for the pens to keep the amount of fencing to a minimum. So let's start by sketching the diagram for the pens. So we need 5. So this is the first, second, third, fourth, and fifth. So these are the 5 pens for us. Let's say the length is L, okay, and the width is W. So we have how many widths? 1, 2, 3, 4, 5, 6. Do you see that? So 6 W. So it is important to make this diagram so that you understand it is not 5 but 6, right? So 6 W. Now what are we given? We are given area of 2400 meters square. So that is the area. So area is length into width. Now this is for each. That means each is 2400. So total area is, so we'll say area equals to length times width. And total area is, there are 5 such pens. So it is 5 times 2400 is length times width. So we could write 5 times 2400 divided by, let's say, length to give us the width. So we have a relation now where we are going to relate width with length. Now let's talk about minimizing the cost of fencing. So cost of fencing minimizing means perimeter we're talking about. So let's look into perimeter now. Perimeter in this particular case is equals to twice length plus 6 Ws. 6 Ws. Now we could write width in terms of length. So it becomes 5 times, and let me write 6 times 5 times 2400 divided by L. Does make sense to you, right? Now what you get here is actually perimeter in terms of length, right? Now to maximize or minimize, we need to take the derivative here. So the derivative for the perimeter is, this gives you 2, and that gives you minus all this number, 6 times 5 times 2400 divided by L square, right? That L to the power minus 1, then minus 1 L to the power minus 2, you get this figure. Now the next step always is to find the critical number. That means that the derivative should be equal to 0 in our case. Now if I equate this to 0, that really means that 0 means that 2 minus this is 0. That means 2 minus all this will multiply later 6 times 5 times 2400 over L square is 0. Or we can write cross multiply this, or we say L square is equal to 6 times 5 times 2400, 2400 divided by 2. So that becomes the length, and from here we can find the length as square root of this, right? So let me find out this. So we'll write length as equal to square root of all this. So we have 6 times 5 times 2400 divided by 2. So let's do it. So we have 6 times 5 times 2400 divided by 2 equals 2, and then we do square root of this answer, and that is equals to 60 square root 10, or in decimals it is 189.7. So I'll approximate this to 190. Is it okay? So I'm approximating this to 190. So that becomes the length, and the units are of course meters. Now, as I said, you have to prove that this is maximum or minimum. Critical number means it could be a turning point either way. So let's find the derivative of this function, which is very important. Second derivative of this will be what? So we are already given the first derivative. Second derivative will be, that is 0. And here it becomes now positive, all this number, which is 6 times 5 times 2400 times 2 over L cube. So this number is greater than 0. Greater than 0 means it is concave up, right? Concave up. And that means we are looking for minimum cost. Is that clear? You have to do this part. You have to show that this dimension is going to give you minimum perimeter and therefore minimum cost. I hope that's clear, right? Now, once we have shown that, we need to just calculate width now. We need to find dimensions, that means calculate width. So width is equal to 5 times 2400 divided by 190. So let's do this. We have 5 times 2400 divided by 90 equals to, in decimals, 133.3. We'll write this as 133 meters. So that becomes the dimensions. Correct? So our answer here is dimensions are 190 meters by 133 meters. So I hope that's absolutely clear. You need to follow all these steps to get full marks in your exam. Now let's move on to the next question. We can have a small break here and watch some wildlife, animals roaming free. Okay, and then we'll get back to our questions.